Welcome to the project demonstration of fast distributed reactive power controller for voltage regulation in distribution networks. So here the voltage regulation and along with power factor correction will be done with help of our microcontroller. So the main application of this project is whenever we are distributing the power due to the inductive loads, the current waveforms and voltage waveforms will provide the differentiation between this time lagging and leading one. So when we are using the inductor, the voltage waveform will lags, then the power factor value will be comes down below the 1. Means whenever the time difference between the phase angle difference between the voltage waveform and current waveform is more than 0 degrees, then the cos theta value is considering as a power factor value. So when the theta is greater than 0, then the power factor value cos theta will be counts down from 1 to below the 0.9, 0.8, 0.7 like that. So when cos 0, as you know that 1, and when cos 10 like that, the phase difference is increases between the voltage waveform, current waveform due to the inductive loads, then the power factor will be comes down to 0.7, 0.8 like that. So that identification will be done by the microcontroller when the phase difference is occurred. Then the microcontroller will add the capacitive load in order to compensate the power factor. Then the current waveform will leads, means inductive load will lags the voltage waveform and capacitive load will leads that. So then compensation will be done with the help of this capacitive load, and that will be done with the help of this electromagnetic relay. So here whenever the power factor comes down to 0.8, 0.7, microcontroller will identify the phase difference between with the help of this current transformer and voltage transformer, and then the system will on this electromagnetic relay, the capacitive bank will be added in parallel to the inductive loads. So pure inductive load we can't measure the pure currents, that's why we have added the resistive load. So here the resistive load R, inductive load L, capacitive load C. So the capacitive load is in parallel with R plus L, and the L is in series with the resistive load. So isolation of this inductive load with the resistive load will be done with the help of this switch. So let us see the demonstration, and so-called status continuously monitoring on the 16:2 LCD screen. So on the power supply, so welcome message displayed on the LCD screen, and initially we are added only resistive load, right? So we have added the only resistive load, then the power factor is lagging here. So let us stabilize that, right? It's lagging now. Though the power factor fluctuates, it will stabilize to certain value, and when we added this, the L was added to the resistive load, then lagging was done and the power factor was compensated to 0.92. So when we remove this L load, right, again it will leading, and the relay will be getting switched off, as we can observe that. So in this manner we are going to compensate in the power factor continuously by using the PIC microcontroller.